And this is week 2 of 6, a booklet for paper 1, the non-calculator paper, our first non-calculator booklet. The plan in the video is to go through certain examples and make notes for you in case you missed the lesson to make notes. It's not to go through every question. I will handwrite written solutions to every question and upload them separately. But this is a good place to start if there are things you don't understand or you just want to kind of catch up on if you missed them in class, etc. So what we've got in here is trigonometric graphs, which is a higher tier topic, so we'll be in the back half of the paper or towards the end of the paper, and direct inverse proportion, higher, again, towards the back. Changing the subject of the formula, intermediate, first half of the paper. Changing the subject of the formula, higher, second half. Standard form, product of prime factors, which may include LCM and HCF. However, they are not on the list. Okay, they're common in that question, but they're not on the list. So I would focus there on the product of prime factors bit rather than the LCM HCF bit. And then dimensional analysis. And again, all three of those are intermediate, so first half. I imagine in these questions here, you've got about 20 to 25 marks out of 70. So over 30% of the paper. So enough marks even in here to secure almost a B grade, okay? Right, so let's get on with it. Let's start with trigonometric graphs. I know this note is starting down there, but I'm going to use this section here just to make some notes for you, which you can copy into a revision book if you're using one, or just take them on board. And we're going to start with a nice pen, and we're going to make sure that that pen is as thin as it can be. Okay. So, trigonometric graphs. You've got to know what they look like. Okay. You need to look better than that, first of all, okay? Start at 0, and the x-axis goes up in 90s. 90, 180, 270. Let's just extend this a little bit to 360. And I'll do the same here, 90. Obviously, you use a ruler. I'm struggling to do that on Word with the drawing tool. I'm sure it is possible, right? And your y-axis goes from 1 to -1. Okay, -1 up to 1. And on this graph side, I'm going to draw sine x. That's the graph I'm drawing. Or I should say y equals sine x. And on this graph, I'll draw y equals cos x. There is a tan graph. Go back through your notes if you need to look at that. However, I'm just thinking in a non-calculator paper. It's probably more common to get one of these, okay? So the sine graph, you haven't got to calculate this. You need to learn this. Starts at 0. The cos graph starts at 1. The sine graph goes up to 1, back to 0, down to -1, and back to 0 in very much a curvy fashion. Do a better job than that. This one curves down to 0 at 90. At 180, it goes down to -1, so curves around to there. At 270, it's back up at 0. And at 360, it's back up to where it started at 1. You just need to do a lot better job than I've done there. Okay, now the question is most likely to look like this. Okay. However, I'm going to just take a little look down here for you to show you the difference. This question, question 2 here, was taken from a calculator paper. The difference being, in the calculator paper, okay, you would have to work out the angle x, okay? So you would have to do something, so say you had that, you need to work out what x is, the angle x was, and to do it, you'd have to take the cos over as cos -1, 0.7. And I think it comes out around 46 degrees, although I think I've got it down here, 45.6 degrees. Okay, however, without a calculator, that's not doable. So my only thoughts and the questions that I found are more likely, instead of putting x there, are likely to give you the angle. So they would write instead cos 45.6 equals 0.7. Okay? With that in mind, I'm going to go back to the question above, the first question here. Where we are, the graph is drawn for us. Oh, thank goodness for that. Okay, that's the first thing. We don't have to actually draw the graph here. However, we are told in this one that sine 38 has an answer of 0.6157. Now, 38 is about there, right? And what we're being told here is that if we go up and across, right, that the answer to sine 38 is 0.6157. Now, in a standard one of these questions, you then have to find the other answer that is the other angle, sorry, that gives an answer of 0.6157, which would involve going across here and giving the other answer there. However, we need to be careful, particularly in a non-calculator paper. If you now read the question, it's asking for what values of x not will give you 0.6157, but will give you minus 0.6157, which is down here. Minus 0.6157. Okay, I'm going to try and be a bit more accurate with this and try and put a line in here if I can. So the line, oops, drag it up, goes all the way straight through there. Okay, so we're looking for two readings here that would give that answer. I think that's, which is here. Okay. Oh, dear me. That's not what you do. Try again. Yes, there we are. Here and here. My apologies about that. It's a bit slow, isn't it? So the answers that we're looking for that would give minus 0.6157 are here and here. However, because this graph is symmetrical all the way along, if that gap there is 38, this is the whole point of giving you this, then that gap there is 38 and that gap there is 38. So your two answers for minus 0.6157 would be 180 plus 38 and 360 take away 38, which are 218 degrees and 322 degrees are your final answers there. We move on. Now, before we get to the next topic, okay, this page is very unlikely. I just want to point that out. The following questions are less likely as they are linked to transformations of graphs, which is a paper 2 topic. It's on the list for paper 2. So I don't think we'll have to transform cos and sine graphs. By transform, I mean move them right, left, up, down, reflect them, etc., etc., okay? However, just to point it out, they're asking you here to draw y equals 2 cos x, right? In other words, all the cos x values would double. So instead of this going up to 1, it would go to 2. And we know the cos x graph normally starts at 1. Well, this one's going to start at 2. However, rather than going down to, sorry, I should put minus here, shouldn't I? Minus 1, minus 2. Instead of going down to minus 1, we're going to go down to minus 2, back to 0, and up to 2. So the only difference here is we've doubled the maximum values from 1 to 2 and from minus 1 to minus 2 here. Cos x minus 1. So we're going to take 1 away from all the values. Well, we just said that the cos x normally starts at 1. But if I'm taking 1 away from that, this is going to start at 0. So at 90, instead of going down to 0, it's going to come down to minus 1. And at 180, instead of normally being at minus 1, it's going to come down to minus 2. However, remember, that isn't a straight line. It would be a curve. It's like the cos graph is like that valley, isn't it? Then round, back up to minus 1, and then back to 0, just a lot better than that. Okay? And add 1. Exactly the same but the other direction. So what was 1 would become 2, what was 0 would become 1, and so on. So it kind of starts up here and does the same thing. Okay? Don't worry about that. Just be aware of it, just in case. Now it's time for direct and inverse proportion. Okay, so let's give you some notes on this then, okay? If you did miss the notes in class, pen should we use? No, we'll use red. I said there are two things that could happen here. We're either going to have a direct proportional relationship, okay? So y is proportional to x, or we could get an inverse proportional relationship. So y is proportional to 1 over x. right? In either case, whether it's y is proportional to x or inversely proportional to x, our next line will involve changing the fish sign to an equals and introducing, and that's the last time we'll see the fish sign, okay? And introducing this k, which is kind of like a conversion factor, or if this was sort of a foreign exchange question, this is your exchange rate, as it were, okay? So introduce the k there, or in this one, you could just introduce the k instead of the 1. Now, I'm assuming here that y is directly proportional to x, or y is inversely proportional to x. In all likelihood, it might be a little bit more tricky than that. So it might be that it's x squared or x cubed, or the square root of x, or something like that, okay? Let's go with an example with x squared, okay? All right. Next, you're looking for a pair of values that allow you to work out k. So it might be, for example, y equals 20 when x equals 2. And I tell you what, we'll stick with that here. We'll use y equals 20 when x equals 2. Now, what that allows us to do is put these two values in here. So 20 equals k, and instead of x squared, we can put 2 squared, so 4. I don't like k4. You could put a times in between them, or you could write them the other way around as 4k, but as long as we realize that that is k times 4, I guess we're all right here, okay? If I wanted to find what k was, I would want to take this times 4 over here, though, and divide by it to get k. So 5 equals k, right? And then we go back to here, that's the big step, and we rewrite it, but with, instead of k, we put 5. So y equals to 5x squared here. Same thing here, okay? We'll put these values in, so instead of y, we'll put 20. We're trying to work out k, and instead of x, we'll put 2. Again, which is 4. But the difference here, because this is an inverse, so we're dividing by the 4 instead of timesing by it over here. So we'll take this 4, and when we move it this time, it's a divide becoming a times. So it's 20 times 4 is k. So 80 is k. And then we go back to the start, or back to this step, my apologies, not quite the start, and put y equals, and where we see k, we'll put 80 over x squared. Again, I've used x squared. Like I said, it could be x cubed, could be square root. That would be part A in a normal question, okay, to do that. Part B would then involve giving you another y value to work out x, or another x value to work out y. It can be a little bit tricky. Easy to work out y when you know x. So let's do one of those here first of all. So if I said x equals 3, and I was trying to work out y here, well, y is equal to 5 times x squared, but if I'm using x as 3, that's 3 squared, so y is equal to 5 times 9, 3 squared, which is 45, okay? And here, a little bit harder, I guess. Let's go with x equal to 4, okay? And then we'd end up with y equals 80 over, but now we're putting 4 in instead of there, remembering to square it, okay, which is 16, and 80 divided by 16 is 5, right? Much more difficult, though, if I do a part C for this one, if I have to work out x when y equals something. For example, I'm struggling to come up with a good example here. Let's go with y equals 10 for a second. It won't work, but just to give you the idea, okay? What we would then do is we'd have 10 equals 80 over x squared. So we swap that y there for 10. We can swap these two around, right? We can take that up as a times and that down as a divide. So we'd end up with not x equals, but x squared equals 80 over 10. So x squared equals 8. So x equals the square root of 8. Now, as it happens, 8 doesn't have a square root, so you wouldn't be left with that exact one, okay, because this is a non-calculator paper, so I'd expect something where there is a square root. If not, leave it like that, okay? But if the number has a square root, give it. Okay. I will take a look, I think, in this one. Okay, so y is directly proportional to the square root of x. So not 1 over, directly proportional. So y equals k, that, okay? And when y is 30, x is 36. The square root of 36 is 6, and instead of times in that 6, I'm going to divide by it over here, and 30 divided by 6 is 5, so k is 5. Back to here, and my final answer is y equals, instead of k, 5 square roots of x. Down to here, there's the pair of values they've already given me. Now my job, put 49 instead of x, okay? So y equals 5 times the square root of 49. That's normally quite an easy one to do. So 5 times 7, which is 35. And then the difficult one, when we know y. 40, which is the answer, equals 5. Well, that 5 is times in that. So if I divide by it, I get 8 equals the square root of x. And unlike earlier where I had x squared, so I had to square root my number, here I've got the square root of x. So if I move that over, I've got to square my number. So the answer is 64. And that's the end of that topic. You try some of the other ones. Next up, we have changing the subject of the formula. Okay. We start with some intermediate questions. I'll explain the difference between intermediate and higher for you. Okay. In intermediate, you won't get fractions, you won't get square roots, and you won't have to factorize at the end. And they're 3 quite big steps. So all you've got to do in intermediate is move the subject term. So this is changing the subject of the formula. In other words, okay, right, let me explain what that is. I don't think I've ever done that to you. If you look at A here, at the moment, we would call P the subject because it's P equals, or in the second one, F is currently the subject. To change the subject would make another letter be equals to something. So in the first question, I want not P equals, I want to change it, move things around with algebra so that K equals, or here, I want to make G the subject of the formula. So we're going to make the subject term, the thing contained in the subject, we're going to move it to the side it's positive, or if it's already positive, leave it in its current position. Okay, this is only an intermediate questions. So if you look at this one, rearrange the following formula to make K the subject. Well, 3K, that is positive, leave it where it is. Whereas this one, f equals 2 minus 3g, and I'm making g the subject. Well, 3g is a negative term, the subject is a negative term, and I don't want that. So I've got the step here of moving that over the equals so that it becomes plus 3g, and then it's positive, okay? Let's do that actually here. 3g equals 2, oh, goodness me, that f, okay? Right, this comes down to the next thing. So I haven't quite finished that line. This comes to the next thing. Move all other terms to the other side. Because I've decided to move my subject here to the left-hand side, everything else has to be on the right. The 2 already is, but the f certainly is not, okay? I know it doesn't have a sign before it, but anything without a sign before it, like the 2, like the f, are positive things. So that's a plus f when I move it over this side, becoming a minus f. So that's that bit done. In this example, I've decided to leave the subject on the side as positive, and I'm moving the plus 2 over, and it'll be negative. I'll let you finish that one though. I'm just going to finish this one here now that I'm here, okay? My third step, divide by the number before the subject, which we call the coefficient. So before the subject here, g, is the number 3, and that 3 is times in that g, and the opposite of that is to divide by 3. Now, I know you've got these notes. I'm going to jot them down really quickly for those who don't. What we're going to do here is this. Remove fraction. Okay, then we're going to remove square roots. Then we're going to collect subject terms. Now, Above, I said, oh, we've got to move the subject to where it's positive, but here we're going to have more than one term with the subject. So they could end up that one's positive, one negative. There's no point trying to make them positive. So in these questions, I tend to, in the higher questions, just always collect subject terms on the left, right? Irrespective if they're positive or negative, it doesn't matter so much here. Collect everything else. Collect other terms on the right of the equals. And here comes the bit that makes it higher. Because there are more than one term contained in the subject, our next thing is to factorize, to take the subject out, okay? And then divide by the bracket. And that won't make sense until we see an example. My example, first of all, I might run two, okay, for you to try. My first one I'm going to do is I'm going to make A is what I'm trying to make the subject. So in my first one, I'm going to go with, what am I going to do? I'm going to do 7a squared, okay, plus f equals a. All right, so far. But I'm going to put that in the square root. Pardon me. Okay, remove fractions. There's no fractions there. There's nothing over something, so that's right. Okay, done. Second part, remove square roots. How do I remove a square root? Well, what is square rooted there? If I move the square root over there, it'll be squared there. So I've got 7a squared plus f equals a squared. Okay. Not the best. I think I'm going to change that 7. I'm sorry, I'll explain this in a second. I'm going to change that 7 there to a d for a second. So it's d a squared, right? Collect subject terms on the left. So a is this is a subject term, dA squared, but this is also a subject term over here, a squared. So I'll leave that one, bring that over to be with it, now negative, but I have to take then other terms that don't have the subject in to the right, and what was plus f is now minus f. Okay, factorize. Take an a squared, in this case, take the a squared that is in both these terms outside the bracket, and you're left with d minus 1 equals minus f, and then divide by the bracket. So a squared equals minus f divided by d minus 1. Now, a step I haven't written here, all right, it only happens, though, with square roots, because you tend up having squareds in there, is because this is a squared, the subject is a, not a squared, so I'd want a equals, and everything here goes, let's put my fraction in, inside that square root, okay? Let me give you another example. Let me go down to this here. Now, this doesn't have a square root, but it does have a fraction. So to remove the fraction, I'm going to take that. Look, notice I put it in brackets, because when I take the divide by that up there, instead of dividing by this, I'm going to times by it, but I want the g to times all of it. So I get 6c minus 3d, right? That has gone now. There is no fraction, because that c plus 2 is now up here being times, okay? Next stage is to get rid, expand the bracket, so times both those things by g. Collect the subject terms, which are the terms with c, which are this one and this one. Collect them on the left. Well, this one's already on the left. This needs to come over and is now negative. This is already on the right, there's 2g, and the minus 3d can come over as plus 3d. It doesn't matter which way around these things are, as long as the signs are correct. So a minus becomes a plus. Okay, and what is plus stays as a plus, for example. Factorize, take the c outside the brackets, you're left with 6 minus g inside. This side not changing. And then divide by the bracket. And that's that. I don't even have to square root this, because there's no squares in this, okay? So this is a lot easier. And in fact, the ones above, other than that nasty one with the square root there, you don't even have to remove fractions. You literally have to collect subject terms on the left, everything else on the right, factorize, boom, done. Okay? Ladies and gentlemen, we are on to standard form. Let's get my pen again. My pen, okay. Standard form, right. A standard form question may ask you to convert a number into standard form and then maybe do a calculation in standard form. I don't expect that this be a problem solving paper for standard form. So, for example, if I had the number 7 million, okay, I would expect you to know to move the decimal point from there to after the first non-zero digit. So it would be 7 times 10 to the power, how many jumps? 1, 2, 3, 4, 5, 6. Or if it was a small number like 0.000428, we would move the decimal point to after the 4, so there, okay? But this time I'm moving the decimal point not up the number to get to its position, but down the number 1, 2, 3, 4 times. So it would be 4.28 times 10 to the power, and because it's moved down the number, minus 4. So big numbers, positive indices. Little numbers, decimal numbers, 0. Blah, 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 negative indices. Fab. Okay, how to add? How to add with standard form. So let's say I had to add 7.4 times 10 to the power 4. And I had to add to that 9.2 times 10 to the power 3. I guess sometimes they put these in brackets. Don't be put off. It's not like brackets like in BODMAS or brackets as in expanded bracket. It's just to show the two different bits of standard form need to be added together. I would bring this out of standard form, times it by 10 4 times. So 7.4 times 10 is 74. Second 10, third 10, fourth 10. Okay? And this one, 9.2 times 10 times 10 times 10. Right? So both actually end up with 1 less 0 because the first times 10 is just moving that there. Then you can add those together, just line them up properly, ladies and gentlemen, if you're doing this method, okay? So the 9 is under the 4 because this has less zeros at the end. Add them up and write your answer in standard form. 8.32 times 10 to the power 1, 2, 3, 4 jumps. Okay, same for subtracting, same method. Okay, so if this was a minus, then we would do 74,000 minus 9,200. So we'd be doing the same thing, but with a takeaway, and then writing our answer in standard form again. So adding and subtracting, big thing, change them to numbers, work them out as numbers, and then change them back into standard form at the end. Times in. Okay, something like 3, let's make it quite tricky. 3.6 times 10 to the power 4 times, I don't know, 6 times 10 to the power minus 8? No, 7? I don't know. Okay, I'm just trying to make these a bit tricky. Okay, with this, better to do things in standard form. Okay, 3.6 times, might need a little sum. 3.6 times 6, might. Okay, don't be afraid to do that. 6 3s are 18, add my 3 is 21. It's 21.6. So it's 21.6 times 10, and now we're going to multiply these. Okay, but when you multiply two numbers that are the same, you can add the little numbers. So it's 4 add minus 7. Okay, because we are adding a minus, well, one of each symbols next to each other, that means we're taking away. So it is literally 4 take away 7. So it's 21.6 times 10 to the power minus 3. However, this is not in standard form because 2. In other words, I need to make this number one place smaller. But if I make that one place smaller, I have to make the indice on the 10 one bigger. And we had this chat in class. If you think about a number line, one bigger than minus 3 is actually minus 2. Right? We're jumping up the number line and in negatives. That can be quite confusing. With dividing, say I had something like 1.8 times 10 to the power 3. right? And I'm dividing by, and sometimes they'll throw a red herring in and I'm multiplying and dividing and actually go, oh, divide by 20,000 or something like that, okay? Well, that's no good to me. I need it in standard form to help me divide. So the first thing I'll do is write that as 2 times 10 to the power 1, 2, 3, 4, right? Okay, then divide the numbers. 1.8 divided by 2, half of 1.8, which is 0.9, times 10. And if you're dividing, you take away the little numbers. So 3 minus 4. So the answer is 0.9 times 10 to the power minus 1. However, same problem again, okay, is I need to, that number is not in standard form. That decimal point needs to be after the first non-zero digit, so it needs to jump there. In other words, that 0.9 needs to become 9. But if I make the number one place bigger, okay, I need to make this number one smaller. So from minus 1, I need to go smaller down the number line. Now I have a little practice at some of these questions. I don't think there are any tricky ones that I really want to pick out. I would be a little bit careful of maybe this one. Okay, 7.2 divided by 2 is 3.6 times 10. And because this is a divide, we're doing 6. However, we take away, I am taking away this indice, and this indice happens to be negative. So just be careful with dividing if you are taking away a negative, because actually you need to add those numbers together, okay, taking away a minus. However, what is nice here is 3.6 is in standard form. It's not something now that needs changing from that, so that would be the answer. So again, you try the rest of those. Product of prime factors may include LCM and HCF. Now, there are a couple of add-on questions, your part B's to this. None are mentioned in this list for November, okay? So I'm doing them as a just in case they've been missed off the list, okay? But your focus here is on the product of prime factors bit. So let's get into doing one of those. You have to be able to divide. Have to. All right. You're looking for your prime factors are likely to be 2, 3, 5, 7. I can't see. It might be 11, right? But they are the numbers now. The example I'm going to use is what am I going to do? 882. Right. Look at the list and decide which one of those would I like to divide by to start with. It's normally a good way to go, okay? 2 probably being the most obvious for a second. Again, you should be able to half this, but don't take any risks. Use the side area to divide it by 2 to see how many times it goes in. 4, 4, 1. Check, go back and check you've done your division properly. One mistake and the whole thing has gone, okay? The fact I've divided by one of these means I know that this one is done, okay? But I know this needs to continue. No point trying to divide that by 2. No point trying to divide that by 5. Potentially 7 or 11. Potentially 3, right? I haven't got a calculator. I've got to take a risk. Let's try and divide it by 3 and see if it works. It's likely to, okay? Because if it doesn't divide by 2 and 5, there's a good chance it will divide by 3 rather than 7 and 11, okay? 3 goes into 4 once, remainder 1. 3 goes into 14 4 times, remainder 2. And 3 goes into 21 7 times. So that was a good choice. So 3 is prime, 147. I doubt it. Again, no point dividing that by 2 or by 5. It could be 7, could be 11, but I'd always bank on 3 until you recognize a number, okay? 147, okay? No, doesn't go into 1, but does go into 14. Again, 4 times remainder 2, and this time that's 9. So 3 and 49, and hopefully now we're in a land where you might recognize 49 and go, I know that I can divide that by 7, and I'll get the answer 7. And I'm there. In index form, because it will ask you to give your answer in index form. So we've got a 2 in our answer, okay, but only one of them. You can put a little 1 there, but you don't need to. Times, we've got 2 3s in our tree, okay, and then we've got 2 7s. Now, a couple of add-ons to this, right? First add-on could be, what would you have to times this by to make it a square number? Okay, I don't want you to get hung up on this bit though, I really don't, okay? In order for something to be a square number, all of the indices need to be even, right? Let me say that again. If you want to make that note somewhere, all indices even equals square number. Don't ask why, we're not going to ask questions here, just if you can remember it, great. Unlikely to come up, but there we are. In my answer here, 7 squared, that indice is even. 3 squared, that indice is even. 2 to the power 1, that is odd, right? To make it even, so I would have to times my answer by 2, so that that 1 then became 2 squared times 3 squared times 7 squared, and then I've got myself a square number. There's an example of that down here, little 1 mark, again, don't worry about it, unlikely. The number, blah, 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 right, is equal to 2 to the power 25. How can you tell it's not a square number? Look at the indice, it's 25, okay? The indice is odd, right? Even indices equal square numbers, basically, okay? Now, in terms of LCMs and HCFs, right, why are they tagged onto this question? Well, LCM, first of all, let's take numbers 40 and, thinking off the top of my head, 16, all right? Best bet, write out your times tables. 40, 80, 120, 160, and then take your time. Just do 16, add 16, just have loads of workers out if you want, just keep going. You've got time, right? Well, and in the end, I've already got to it. So it's my lowest common multiple, the lowest number that 40 and 16 both go into. Yes, they would go into 160, but there's a lower one, there's 80, okay? HCF is the highest common factor, right? If they ask an HCF question, it's likely that the first number they give you, you'll already have done a tree for. So I might say, what is the HCF of 882 plus, what have we got? 175, okay? Let's try that. Hopefully it works, I don't know. No, it doesn't. Let's make it 105. Okay, so what's the biggest number that goes into both of those? You can see that would be tricky. Now, we've already got that 882 is 2 times 3 squared times 7 squared. 105, if we just quickly do this here, 5 goes into it. If you divide it by 5, you get 21. And if you divide that by 3, you get 7. So they are all prime. So it's 3 times 5 times 7. To get the HF, what you can actually do is look for things that are in both. So it's sometimes better to not look at these in index form. So this is 2 times 3 times 3 times 7 times 7, if I wrote it out in full, okay, rather than squared and 7 squared. So there's a 3 here, and I've also got 1 in here. There's a 7 here, and I've also got 1 in here. There's a 5 in this one, but there's no 5 in this one. And there's another 2, a 3, and a 7 in this one, but not in this one. So the only things that are common to both are 3 and 7. And if you times those together, you'll get 21. And that is the highest common factor. So whereas LCM, you're just literally writing times tables, HF, there is a little bit of a method which uses these. So to give you an example of that, you've just done 315 as a product of prime factors, and this is asking for the HCF of 315 and 42. Well, down here, do 42, 2 times 21, 3 times 7, and look which ones of those numbers are also in this answer up here, and times them together. It could be that there's a 2 and a 3, it could be there's a 2 and a 7, or a 3 and a 7, blah, blah, blah. All right? But you give that a good go, and that's the end of those. Okay, dimensional analysis. It's an intermediate question. I can't think of how else this can be asked other than this. It's in the list. again, I'm surprised because the list is quite big, which we'll talk about in class. For paper 1, certainly. Paper 2 looks a bit more standard. I'm doing it because it's there. It says it could come up, so we've got to do this. Okay, so what we're looking for here is this: any two letters times in together. Now, there are a couple of ways to times two letters together. Right, it could be by something like AB, that would be two letters together, or A squared, that would be two letters together. Times together, I mean, okay? Anything like that is an area. Any letter by itself is a length, like A, B, C, whatever. Any three letters timed together, for example, A, B, C, or A cubed, or even A squared B, which is two A's and a B. All of those are three letters timed together, and is a volume, is three-dimensional. So you've got two-dimensional, 2D, which is area, and you've got 3D, which is volume. My apologies, these are three different things, and these are two different things. Any numbers like pi or and numbers, let me write that, pi and numbers, should be ignored when deciding if a formula is an area, a volume, or a length, okay? And the other thing I would say is expand brackets before making your decision. Okay, that's it, really. So if we read what a question might be worded like, in the following formulae, each measurement of length is represented by a letter. So every letter is a length. Consider the dimensions implied by the formula. Write down for each case whether the formula could be for a length. So our options are a length, an area, a volume, or if we've got a mixture of things, we could write none of these. And they've started with the top one here, where they have put d cubed, d times d times d, right? Three letters times it together, that is a volume. Take away 3.14, which we know is pi, and we're going to ignore numbers anyway. So I'm just looking at the r squared h, r times h, which also is three letters, so it's a volume. So this is a volume, taking away another volume term, so it's still a volume. Here, d times d is an area, it's two letters times together. H times W is two letters times together, it's an area. So it's an area term plus another area term. So this is an area. D is a length, W is a length, and H is a length. So we are adding a length, add another length term, add another length term. So this is a length. Okay, here I've told you to ignore numbers like 2 and like pi. All right, and pi there. Don't ignore squares, okay, and cubes, because they're not numbers. They are telling you that letter is times in by itself, okay. So what we've got here, if I get rid of the 2 and the pi, I'm left with r on its own, which is a length. If I get rid of the pi here, I'm left with r squared, which is an area. So it's a length term, take away an area term, which is silly, doesn't make sense. So you'd write none of these. Okay, here I told you possibly better to expand brackets before we start. Probably more usual to see the W at the start of the bracket than the end. However, it just means W has to times both these things, no matter which side of the bracket it's written. So it would be DW plus HW, right? Which is, I should have done that over there really, because that's not my answer. This is an area term because it's got two letters times in. This is an area term, so the answer is area. And then down the bottom, d cubed, which we know to be a volume, and dWh, which we know to be a volume. So that is a volume. If they wanted to do more of a problem-solving thing, they could do something like that and say one of the following formulae may be used to estimate V, the volume of the solid, and so they're basically saying which one of these is a volume, okay? And if you look at it, all right, that's a length. That's because it's a length. This is, if we lower the 3 and the 5, that's a length plus an area, so that's none. If we ignore the 3 there, we've got r squared h, which is a volume, plus, if we ignore the 2 there, r squared d, which is a volume, so that's a volume. So that's the one that should be used, okay? And then the bottom one, we should expand the bracket. So 3r times 4d is 12, 3 times 4, rd, which if we ignore the 12 is an area, plus 15 RH, and if we ignore the 15, that's an area. So what we've got here is a length formula, a nothing formula, a volume formula, and an area formula. Okay? And then question A, explain why this one cannot be used for the volume. Well, it's a one marker, don't commit too much. just say words to the length, it's one-dimensional. You can even get away with saying it's a formula for length, or it's length terms being added together. Okay, anything like that, and then state with the reason which of the following may be used to estimate the volume, and you can quote the one that we said earlier, and your reason would be it's three-dimensional. In other words, it's three letters. Sorry, multiple as well. It says which of the ones, so you need to put that as well. And that's it. So that's a different type of question, but it's more normal to see something, I guess, like that. You have a go at the rest of those. That is the end of this booklet. Hope it's helped you a little bit. Fill out as many answers as you want. Give it in to me. I can mark the rest, and I will give you model solutions later on nearer the exam time. Bye-bye.